Hello. I hope everybody can hear me. I cannot really hear you, so maybe, I don't know, maybe it will work. So, hi everybody. I am Matteo. I'm Matteo Collina at Matteo Collina on Twitter. Please follow me. Maybe from time to time I tweet about things interesting in the Node.js world. I would have really loved to be there at Node Tel Aviv, but you know there is travel restrictions in place, and I couldn't really travel to Italy. So hey, that's it. And so I'm going to deliver these remotely. Let's go a little bit. Talk about NearForm. I work for this company called NearForm. We help other companies develop modern JavaScript application, both front-end, back-end, and also design and DevOps, and so on and so forth. So most of my work on open source is sponsored by them. So hey, thank you, NearForm. We are also adding remotely from time to time. So if you are, looking for a job or something, check out our website. So let's get deep very quickly into what is a stream. Some people way more smart than me said that a stream is just like an array, but spread over time. Instead of having a set of value that is fixed and located in memory, we receive values and receive data as soon as it comes up, as soon as it's available. And it's great because streams allows us to deliver, to move, to consume data with a fixed amount of memory. You see, data arrives over time, so we don't have to allocate a very big array to control everything. So hey. Well, this is the moment that I cannot really hear you, but I'm going to ask you to raise your hand because I can see you. Who understand Node.js streams? Hey, somebody! I see some hands, a few of them. Okay, hello. Fine. Since my interaction with the crowd is working, I cannot hear you, but I can actually, see you. That's great. Okay, so we are a little bit of a silent mode going on here. So that's fantastic. Well, let's go a little bit closer into this. And maybe I know the people that know streams. I don't know if you know you, but hey, if we have met, I'm sorry, I'm not there to check. Node.js streams are based on event emitter, which is one of the oldest abstraction that Node.js introduced. You will see that Node.js streams emits a bunch of events, and they also have a nice destroy function. They can originally, in order to consume a stream, you can only use on data, and they will, emit chunks. Then we added readable. We'll see that in a moment. There is a close event that signals certain things. There is an end event and finish event. Now, close and finish are all synonyms, right? More or less. However, they mean three completely different things. So we'll try to demystify them in a second. Also, stream.destroy is your best friend. It's very important to call it the moment there is some error condition or anything, because it allows us to actually clean up the stream so that you don't have any more data and you're not leaking memory at all. So, or not leaking a file descriptor, for example, or other things. So at the very beginning, how did we read data in Node.js? Well, we used this very nice syntax, which is stream on data, and you will be passing a function. This is a nice ES6 syntax, whatever, and which we emit a chunk, and this chunk, and then we will do something with the chunk. And then it will meet end when the stream was finished, was done. Okay, this is a readable stream, so it's fine. Well, these had some problems. The reason for that is because it's push-based, so the stream will actually continuously emitting data. So in this mode, we needed to signal if the consumer was busy, we had to call stream.pause and tell the stream that, well, please slow down. And then later on, we wanted to resume data. Well, this is not really easy to do because there's a lot of things that can go wrong here. So maybe not great. Note that at the beginning, stream.pose was actually advisory only, so it might work, it might not work. It was really fun. These were Node 0.8 days or something like that. So around 0.10, Node 0.10, 0.12, this new readable event was created, and stream on readable, and then you consume. This event was the readable event is pool based. So what it means is that it's emitted when there is data available, and then we get the data calling stream.read in our while loop. And we do something with the chunk. And this is actually better because we get data when it's available rather than pausing if it's too much. So and it's a little bit more performant than using pause and resume and things like that. Yeah, but this is not really easy, right? I don't like it. Also, in all of this, Azure handling is super complex. So let me ask you a question. Again, I cannot hear you, so I will ask you to raise your hand if not true. How many of you have tried to have done this to send a file over HTTP? Please raise your hand. I see somebody nodding. I don't know. Hey, okay, you've done it wrong. I'm sorry, guys. It's really wrong. Hey, if you've done this, it's not really great. I will ask why, but again, I can't hear you, so fine. Well, in order to correctly stream a file over HTTP, you have to go to use pipeline. Why? Because you need to automatically destroy the response. Sorry, guys. To automatically destroy the response if there is an error. So that's what pipeline do. This is a new operator in streams that you can use, and use pipeline to you do your thing. Or you can just use a framework. Well, I wrote Fastify, so whatever. You can just use your framework. By the way, if you don't use pipeline here, what happens is that the response is not closed if the read streams has an error. So essentially, or the read stream is not closed if the response has an error, which means that you can actually leak a file descriptor, which you have a very limited amount in your system, and that will grind out your application to on hold. So this is a nice question, and let's go and look at and finish and close. So end is emitted when a readable stream is has no more data to read. For example, a file is we have read all the content of a file, or a socket has been closed successfully. This is a successful condition. Okay, it's successful. Finish, it's when we have closed. It's emitted when a writable stream has been correctly shut down, which means we have finished writing to a file or a socket. When is close emitted? Close is emitted in both cases, but also if the stream is emitting error. So if it's emitting error, it's an error condition, and after the emit error, streams are really in a bad place. So they're not recoverable, and we will emit close to signal that streams are done. Okay, so that the internal resource has been correctly collected. So, well, all of this is about recapping streams, and we all know that streams are really hard, right? That's what we know. So that's what we know. So, well, all the best features of Node.js streams or Node.js relies on streams. Also, the JavaScript community loves async await and promises. How many of you use async await every day? Hey, hooray! Okay, I hope you folks that don't please start or something. Well, that's the hard truth. All those event emitters and so on do not work well with promises. It's really hard, and you can make a quick mess about it. And also, we cannot really change the behavior of node streams, otherwise we'll break everybody. So they are most of the API is actually kind of legacy, so we cannot really change it, even though we would. So how can we improve the usability of Node.js streams? Well, most of the focus of this talk is about async iterators. How does an async iterator work? Well, you can create, there is an async generator and an async iterator. The async iterator is the second part. You have an async function and you do for await, let chunk of iterator, for example. And then you can create one of those very quickly by using an async generator, and that will return an async iterator. So, and you can use yield, and you can await sleep, and so on and so forth. Pretty nice. We worked very hard a long time ago to make sure that async iterators, that Node.js streams were compatible with async iterators, and they work well. So what you can do right now in all supported line of Node.js 10, 12, and 13, you can create a read stream, for example, and then iterate the file chunk by chunk. And you can just run this. So it's actually pretty nice. We have also in Node 12, but I think it might be ported in Node 10, so that's false. In the latest Node 10 release, you can also do readable.from and pass in a generator or an async generator, and to convert it from a readable, to convert into a stream. So essentially, if you want to have a very quick way for creating a streams for testing purposes, or to generate some data from, I don't know, a database or whatever piece of your system, you can actually do, you can actually use this kind of syntax. Note that, in fact, you will see that, so these are generator, but also async generators. And you can call, again, you can call it, and you get your stream, and it just behaves like any other stream. It works perfectly well. So this is about the demo gods, with the demo gods, that the demo gods should be with me. I hope you all, can you raise your hand if you can read my screen? Okay, fine. I hope you can read it. So let me make one step bigger. Here we go. So the first thing I want to show you it's this. And it's similar as before. So like we want to create an array that spits out some values from 1 to 1024, and when the read is called, it will emit all those values and will print them on the console. So let's run this, and yeah, it's working as we expect. Okay, so wait just a second. Okay, so let's go to the second demo. Now, with readable from is actually pretty nice because we can also pass in an array. So we can pass in an array with the same values, and we'll see that it works the same. Again, we still get all our kilobyte of values. Let's see the third step because it gets interesting. Now we can now use a generator to yield all the values. Pretty similar, and let's see. Still working as expected. Now, if you go into the third JS and sorry, if you go over to this, okay. If you go into this, you can see that we move this for loop into the function. So in theory, we can allocate less memory. In fact, we can also make it asynchronous and consume it asynchronously. So we are now consuming the chunks one by one without using on data. So let's see. Yeah, it still works fine. And sorry, make a mess. I'm making a mess. So this is my example. Note that I can also use an async function here, and it will still work as expected. Here we go. Now, one of the things that actually pretty nice is that I can easily get a promesify here, and here we go. And then I can do a sleep. Yay! And then let's see that I'm adding an await here, so of 100 milliseconds. Now, if I'm running this, you will see that now there is a little bit of a delay, and that's what I would like to have, and it's actually working very well. So basically, we are adding a delay, and we are yielding our values, and those are actually allocated one by one when there is a need. So hey, here you go. Nice. Okay. So, well, I've done this. So now we can also read a file. So if you really see this, we can create our read stream and set the encoding because we want strings, and then Node 6. Now you see that we are printing our file, which is pretty nice. And here we go. We can print our file, and we can also do, for example, a 2 uppercase. So, and run it. Hey, so you see it actually working as expected. Note that __ file name reads the current file. So essentially, we are reading this script and printing it out one by one. Well, let's go into a little bit on the future. So, what is missing? Well, one of the things that is missing is, for example, converting an async iterator to a stream, to a transform stream, which is a nice syntax, right? This is actually work very well. Well, this is a PR open by David Mark Clemens, so you might chime in if you. It's a little bit stalled now, so we'll see, but it's there. Something that is actually very nice, could be very nice, is we can actually even avoid creating a transform, essentially making pipeline async iterator aware. So we could pass, for example, a create read stream, a function, and a write stream. It's a very, very nice syntax. Well, the reason for this is that we could avoid buffering. So one of the things that streams do is buffering, because you have back pressure logic and so on and so forth. So, and it does a lot of buffering, and this can be actually pretty nice and use less memory. Well, this is already landed in Node Core, not released yet. Thank you, Robert, and I'm going to demo it right now. So let's go into pipeline 1, and so this is how it works. So essentially, we can create compose function like this. So we have async function star uppercase, for example. This will yield our chunks one by one. And this just counts the counter, just counts the values. So it's another async generator function that iterates over the stream and just count the length of the chunks. And here we pipeline res, uppercase, counter, and process td out. Note that these will not work with Node. It just throws an exception because this is Node -12, doesn't have it. Well, what we do is, I am here, I have a nice, this is 14 pre as it. Don't use 14 pre anywhere, please. And so let's run it, and you'll see that it's actually working as expected. And I see you guys a little bit perplexed, so maybe I get questions later on. So if you are, so it's actually a very nice syntax and a very nice way of composing streams and processing. Note that you can add as many, like this will be something like this. You can add as many as you have. Here we go. So you can add as many steps as you want. Note that in fact you can also just work with async iterators, so and async generators. So you can actually pass in a generate function, new lines, uppercase, counter, and so on and so forth, and without using any streams, minus process td out at the end, or even nothing if you don't want to. So let's run that node pipeline 2. Here we go. Okay, so now you see that this is actually printing the data one at a time. No, there's no zombies here. I don't know. It's a little bit of the zombie outbreak. So, okay. So it's actually a pretty nice API. You will see it coming in some node near you. Well, what about Writable? Okay, how can we use Writable? We have talked about readable, transform, pipeline. We haven't really talked about Writable. So, well, this is kind of the best we can do right now. Yeah, there is a typo here. Nice me. We can use this once operator here that is from events, and we can do if we want to pipe to streams using AsyncIterators, we could potentially call dash.write and call once await once dash train. This is very important so that we keep writing until there is space in the destination buffer, and then we destroy everything. That's it. Not sure if it's nice or not. We don't have many better ideas, and it's not really simple to build some utility for it. Well, I'm almost out of time, so I don't have. I'm really running late for some reason today. So I don't know if I can keep going or not. Somebody let me know over WhatsApp. So all of this was just because it's JavaScript, and it's based over the AsyncIterator. It's based on the AsyncIterator protocol. What does it mean? Well, it means that in Node Core we implement this symbol.AsyncIterator function in readable or in readable, and we just create our AsyncIterator from here. How is that implemented? Well, you need to create an object which has this async.next function and this async return, and there are a bunch of others. And you need to set the prototype because that's what the spec says or something like that. We use the readable event internally, and you can take a look at this file, and it's kind of big, but you can actually have some fun in digging into Node Core. From what I know, there is not performance penalty in using AsyncIterator with streams, but if you have benchmarks or stuff, we're happy to take a look. Last but not least bit. Here we go. Last and not least, there is a WHATWG stream, which is what you use on the web, which is, for example, fetch. And with fetch, you have this pipe 2 pipe 2. And you probably, how many of you use fetch? You use fetch, right? You've used fetch. Yeah, a lot. And however, if using fetch is not simple. You have this controller thingy, and it's not nice either. Okay. And yeah, it's not nice. It's complex. It's as complex as Node streams in different ways. So hey, these might come or not come to Node Core in the future. It's probably something that's going to come in Node Core. However, most of this is tied to the Node.js ecosystem. It's how do you migrate? How do you create an compatibility layer? Well, WHATWG streams are going to be AsyncIterable pretty soon, if not already. So you could, in fact, use the pipeline operator to combine them all. So we already have our nice compatibility layer. And, well, we can say now that Node.js Stream works well with promises. And if you want to get involved, Node.js is always looking for new collaborators. So please reach out. There is Benjamin there and a lot of other folks from the Node community. So reach out to them, and they will kind of help getting it. Again, I'm from NearForm, and thank you for having me here. Follow me on Twitter, by the way. And I will have a Q&A slot later on in the day. So, perfect. Bye, guys. Bye-bye.